Welcome one and all to this first episode of D and Other D with my second daughter Lilith, who is 7.5. Say hi, Lilith.
Hi.
And we are going to be working on what is effectively our second game together. She knows very little for now, so I'm going to be explaining quite a lot of things. I won't be interacting with chat too much while we're doing this. This is going to last approximately 1 hour. So let me quickly change this here. Projects. Do we have something with your name on it? Lilith Projects. There it is. Okay. So we're going to go to Lilith Projects, select folder, and then we're going to give it a new name. Let's call it Lilith Puzzle. So capital L. She's going to be doing the typing. Lilith Puzzle. No spaces. Capital P. Camel case, it's called. Roger, look. Bye. Okay, Lilith Puzzle. So, we were discussing whether we go 2D or 3D. Now, do you know the difference between 2D and 3D? What does D stand for? The letter D.
Don't know.
Dimension. Do you know what that means?
No.
Okay, how do we explain this to a 3-year-old? What am I saying? To a 7-year-old, sorry. Okay, so when you look at the screen, for example, the screen in front of you, you see a flat image. Do you notice that? It's flat, right?
Mm-hmm.
Okay, and look, a page as well of a notepad. It's flat, isn't it?
Mm-hmm.
Yeah, this means that there's a vertical space and a horizontal space. But does it have a thickness, the page? Could you write on the side like this?
No.
That's right. So this is 2D, 2 dimensions. Horizontal, vertical. Okay? But if we take a bottle, for example, a bottle has a height, a width, and a depth. If it didn't have a depth, it couldn't contain anything, could it? Okay? So it's 3 dimensions. Three lines you can measure on: vertical, horizontal, and depth. Okay?
Okay.
Now, because our game is going to be about a picture that gets dissected, right? We are not going to need a 3rd dimension. We don't need depth. So we're going to go with 2D. And we're going to create. Okay?
Okay.
So now all we do is wait for a bit for the project to get built. And there's going to be a bit of experimentation in this project because I'm not exactly sure about what it is that we need to do. That's interesting. I'm going to have to do some research myself at some point. So the game we're going to make is basically a game that is going to take a picture and it's going to put it somewhere on the screen and it's going to dissect it into different boxes. Okay, and then it's going to scramble all the boxes. And you're going to be able to click on a box and then click on another box and it's going to swap the 2 boxes until you correctly build the picture. Does that make sense? Okay. So, let's begin. This is our scene. It's totally empty. There's only a camera and nothing else. Okay? So the first thing we're going to do is we're going to right click here. We're going to select UI. And we're going to create a canvas. A canvas is basically a menu system in Unity. Now check this out. Look at how far out I need to go. Whoa, you see this big rectangle? This represents your screen. So this is what your camera sees. And this thing, this big rectangle, gets splatted on top of the camera. And it will fit the screen exactly. We're going to make a few changes here. Look, here it says UI scale mode. UI means user interface, which is basically menus, okay? Constant pixel size. That means that it's going to be as large as you specify by number. But we want it to be the same as the screen. So we're going to say scale with screen size. Okay?
Okay.
Reference resolution. We're going to put the typical resolution of every screen. Well, most screens, which is 1080p, they call it. which means 1980 on the X, and excuse me, 1920, my bad, on the X, and 1080 on the Y. This is the widescreen standard resolution. Okay, what a resolution is, it means this: how many pixels, which are basically colored boxes, are on the screen horizontally, that will be the X, and vertically, that will be the Y. So in this very moment, from down here where my mouse is to all the way to the top, you have 1080 little squares that have a color in them. When you put all of these squares with colors together, you get a picture. Those are called pixels, okay?
Okay.
So we're telling our screen that it's always going to be like this, match with, sure, whatever, reference pixel, we're gonna leave that alone. And there we are done. Okay?
Okay.
So our canvas is ready. Now inside the canvas, we can keep on building things. We're gonna go down to UI, and we're gonna select image. Now look, a box has appeared in the middle of the screen. If we go to the game, there's your box. See, right in the middle.
Mm-hmm.
Now we want this box to stretch all around the screen, don't we?
Yeah.
So, see here, it says rect transform has got these things. These are anchors. This is a bit complicated, but let's see if you can understand following with me. Okay? So, here you have the indication of what is called the pivot point, which is basically the center of the image. We want the center of the image to be in the middle, like this. So that's good. Okay? But we also want it to stretch all across the screen. See here, this would mean stretch vertically. And here, this means stretch horizontally. If you want to stretch both, you would select this. Now, watch these numbers over here. See, 910. This means it's 910 points away from here. So how far away do we want it to be from here? What do you think? What number? If we want it to be absolutely attached.
0? I don't.
0. So what about from the top? How far do you want it from the top? If this is 490,
Mm, 600.
600. Okay. Whoa, that's giving us an error. It's going too far down, even further down than the other part. It's going to be 0 again. It's 0 far from the top, right? How far from the right? Think about the question. How far from the right? No, I didn't say you how far to the right. I said from the right.
I guess.
10. There's a small amount of space. Is that what we want?
No.
So?
Something a bit smaller, I guess.
How smaller?
9.
Why 9? Like, why are you giving me random numbers? How far from the right do you want it to be in order to be fully flush?
0.
There you go. 0. So what about the bottom? How far from the bottom?
0.
Yes. So 0, 0, 0, 0. We want this picture to cover the entire screen. Okay? Now let's go on the internet and find some picture. So here's how we're going to do it. We're going to go to Google, which I don't really use, and I'll show you why we'll use Google. Okay? So look for a picture. What do you like? You like harpies or something, right? Birds. Mm-hmm. So what are you going to look for? An eagle, for example. Eagle. And hit enter. All right. Now we're going to select images. Okay, there's a few eagles. And now we're going to go to tools. Google has this. First of all, usage rights. We're going to select labeled for reuse with modification. This means we can change it as much as we want. So these are all free pictures that we can use in our game. Secondly, we're also going to change the size. We're going to go to large. I don't really like this setting. I would prefer a specific one, but I don't think it's possible to choose it. It maybe there's a sort of whatever, I don't know. But remember, ours is 1920 by 1080. So we need something that is going to help us in that area. This one's huge. Look at the number, 4007 by 3200. But it could be all right as long as the aspect ratio is fine. All right, which I don't think it is in that case. So this one would be good, but not really for a puzzle, because it doesn't have sufficient details in the blue areas, okay? We need to have a picture that has details everywhere. So I say this picture could be okay, but it's a bit small. This picture could be okay too. Which one do you like best of these? Something that doesn't have a full blue sky, for example, that we need to avoid. This one's not a bad picture too, even though it's got nothing to do with eagles.
Oh shit.
Yeah, this one could be good for our game. Well, let's copy this one for now. So we're gonna copy image. Now I want you to press the Windows key there, bottom left, the one that has a little window on it.
This one?
Yeah. And now type GIMP, G-I-M-P. Oh, look, it's already there. Let's open it. Okay. And in chat they tell me we can choose specific size by changing to that individual size in custom. I don't see any custom. Maybe settings? Search settings, advanced settings, maybe advanced. It's fine. It doesn't particularly matter. We'll be okay. Now I want you to paste Control V. Okay. Now, image, canvas size. So you see it's very, very big. Okay. We are going to change the image and make it a little smaller, but you can see something here. You can see that there's some white space over there, right? So let's go to View, Snap to Canvas Edges, pick from here to here, and then we're going to say Image Crop to Selection. This one will cut away that bit. Okay, so now our image looks right. Now we're going to say Image, Scale Image, and now we're going to tell it 1920, 1080. Ooh, it squashed our ship. That's not good. Hit Control Z to undo. So here's what we're gonna do. We're gonna scale image, and the most important part for us is the width. So we're gonna go, oh wait, but it did squeeze it, didn't it? We'll see. Let's go to 1920 and scale. Okay, now it's correct, but it is too tall. So what we're gonna do is we're gonna say, let's see, canvas size, and let's go with 1080. Okay, so you can see here, it's squeezed the ship out quite a bit. That's not good. So hit Control X to cut, Control V to paste, hold Control to move in a straight line, and we're gonna go up to about here.
Let go.
Yeah, release. Okay, and now let's redo that image canvas size 1080, and it's cutting a bit of the ship. I'm not happy with that. Let's undo. Control Z. No, that was not Control Z. Try again. Okay, that's better. Cut again. Paste. Hold Control. Wait, release it first. Now hold it. Okay. Now let's see if we can cut a bit of the top and leave the rest fine. So again, canvas size 1080. That's much better. And there we go. There's our ship. I mean, it's not perfect, but it's fine, right? It'll do for our purposes. Now I want you to press Control-Shift-E to export. Control and Shift. This is Shift. And now E. The letter E. That's the one. And we're gonna go to one of the folders here. So we're gonna show this in Explorer, Assets, copy this, Control C, go back here, Control V, hit enter. And in here you can save it as ship. Bless you. Ship.png. Bless you again. PNG. No, PNG.
PNG.
Oh, my bad. I think you understood PNG. I meant PNG. Alright. Export. Now it's making it. And now you'll see that here in your game, ship has appeared. There it is. Okay. It's a sprite 2D and UI. That's good. Pixels per unit, we're probably going to leave it alone. It doesn't particularly matter, actually. Sprite mode single, that's correct. Pivot center, that's fine. Don't generate physics. We're not going to need any special boxes for this. Alpha source, that's fine. Wrap mode clamp is fine. Filter mode bilinear is fine. Normal quality is fine. All of this is okay. So we're going to select apply. Okay?
Okay.
Now, I want you to look at one thing down here. See, it says npot. You know what that means?
No.
Not a power of 2. Do you know what power of 2 means?
Power of 2, guys? I don't know.
I'll show you. It's a mathematical concept. So if you open a calculator and you need to do the family of number 2, you start with 2. Times 1 makes 2, right? Mm-hmm. Okay. Now what if we were to multiply 2 by itself many times? That would be a power. So for example, this one is 2 to the power of 1. It's multiplied by itself once. What if we multiply by itself twice? 2 times 2, 4. That's 2 to the power of 2. What if we do it 3 times? 2 times 2 times 2, 8. That's 2 to the power of 3. Okay? 2 times 2 times 2 times 2, that's 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, etc. As you can see, it starts growing very quickly. Okay, we call that exponential growth. Now, what's happening here is these numbers that I've just shown you is how computers like to understand sizes of things, in particular pictures. Now, you can see these numbers don't match these numbers. So, it's not a power of 2. This means it's a bit of an inefficient picture to save. Complicated concept, I know. But it's okay. Alright, so we've got this here. Now one thing we need to do is we need to do read-write enabled. If we're going to be able to cut it, we're going to need to tell Unity that we need to be able to actually change this picture. Modify it. Okay?
Okay.
Now that's going to be interesting because I don't actually know how to do that on the fly. Okay, but here we go. Let's go to the image over here. Let's rename this one from image to, let's call it puzzle area or something. Go, hold shift and call it puzzle area. Area. Puzzle area. Okay, and we can give it a picture. We now have the ship. There it is. Now your game looks like this. Okay?
Okay.
Now we're gonna have to figure out how to cut it. And that may be peculiar, interesting. Okay? We need to decide how many squares we want to cut it in. Maybe we should have a few different modes. What do you think?
Sure, a few different modes would be fine. Sure, a few different modes would be fine.
A few different modes would be fine, you say. Okay. Yes, so we can chop it up in parts and then we'll decide. So let's create a new folder here. Call this one Sprites with a capital S. Do you know what a sprite is?
No.
It's a 2D picture. like your ship. So we're going to drag the ship into the sprites. Then we're going to create a new folder, which we're going to call scripts. Okay, and this we're going to
why do two say
what?
Oh, never mind.
What?
I thought the two said scripts, otherwise instead of
They both say scripts? No.
Was sprite.
This is where our code will go. Okay, so we're going to create a new C# script we're going to call Game Manager, capital G A-M-E, now manager with a capital M. Hit enter. Okay, cool. And here we're going to create an empty object, which we are going to reset. Look, it gave it really weird positions. Let's reset it. There we go. Okay. Easy. Puzzle split into 4 pieces, says Rob. Well, maybe we agree. Put the word manager here with a capital M. G-E-R. Hit enter. Okie doke. And now we can drag our game manager onto here. So now the game manager exists. So we've got the back picture. Now, remember, we're going to have to split it into different parts, right? Now, let's think this through. We're going to make it so that we can click in these different parts, but that means we need to have various buttons. Well, that's not that easy. So let's see if there's a button we can create. UI button. There is one. That's cool. There we go. Okay, so it's shaped like this. Here's what we're going to do first. We're going to take this and we're going to lower this color so it's kind of visible through. We're also going to do another thing. We're going to remove the text because we don't need it. We just need this thing. Okay?
Okay.
Let's color it red so it's nice and visible. Okay? But as you can see, it doesn't fit. Now, there are ways, remember, we could use this to make it fit. So if you do this and then you tell it 0, 0, 0, I'm going to show you a shortcut soon, it fits the entire screen. But we don't want one single button, right? We want many buttons for as many cuts as we have, correct? Okay, so that means we need to have either some form of grid system, which we could use. We could use a grid system for the buttons, or I think I would prefer a system made of horizontal lines and vertical lines. And it will depend on how many we have. So let's create a UI object, an empty object, which we're going to call row. So call this one row with a capital R. Now we're going to put the button in the row for now, and I'm going to fit the row flush. Now remember earlier how I select this and then I go 0, 0, 0, 0? There's a way to do it faster. If you hold Control and Shift here, Alt and Shift, see how this changes? Alt means flush it and Shift means pivot in the middle. So if I do this, boom, and you'll see that the button became gigantic. So we need to do it on the button too. There we go. We're back to normal. So here's the row. Now the row is going to have multiple buttons in it. So hit Control D a couple of times for me. More. Okay, what's happening here? Look, they're putting each other on top of one another. That's not what we want. What we're going to do is we're going to tell the row, add component, horizontal layout group. Now everything's disappeared. Now we're going to say control child size, width, and height. Look at what happened. Can you see? One button, another button, another button, and another button, and they're exactly the same size. Isn't that interesting? Yes. Okay, sounds good. Now, we said we also need to make a bunch of rows, right? So duplicate this row, for example. Look, this one is also being put on top of the other. So, if there's a horizontal layout group, surely there is a vertical layout group too. And there it is. And again, we're going to say regulate the width, regulate the height. And now you can see we have 2 rows. Each of them has 4 blocks in it. For example, duplicate this row again. And look, now we have 3 rows with 4 buttons each. You see how everything is neatly placed?
Mm-hmm.
That's quite cool. Okay. In fact, if we start the game, see, we can click the buttons. Okay, now it's not very clear for now. We're gonna have to work on this a bit, but it's fine. I'm not worried. All right, this is a beginning. So we're gonna need a few things. We're gonna need to save the buttons, and we're gonna save the rows as well. Now for the buttons, I don't actually know if we should have our own buttons like that. Maybe. Because they would need to know which button they are. We'll see. Because when you click them, nothing happens at the moment, as you saw, right? But they do have certain stuff that happens to them. Well, but first of all, whenever we hover on a button, right, we would like to see some kind of outline, correct? Okay, so let's go and create an outline system. Okay, so we're gonna do a new file, and we're gonna tell it that it's going to be 256 by 256. Why do you think I picked this number? Why 256? You can't know this unless you remember what I said before. Because it's a power of 2. So I'm trying to make it easy for the computer to size this appropriately. Okay? So now what we're going to do is we're going to delete the background. We're going to add an alpha channel, delete the background, and we're going to create a new layer. Okay? And what we're going to do is view, snap to canvas edges. We're going to create a square over here, and then we're going to make it smaller. I'm going to shrink it by, say, 24. Okay, that's maybe a bit much, but that's okay. Now let's select the brush, edit, stroke selection, stroke with a paint tool, stroke. It's made a black outline. You see that?
Mm-hmm.
Okay, it looks a bit big to me, but that's okay. Let's invert the colors. We're gonna need it white, and that's basically all we need, at least for now. So hold Control Shift and E, and we're gonna send it to sprites and call this one highlight. Capital H, highlight. Hit enter. Okay, and now highlight is gonna be here. Now highlight is a bit of a special thing. It's gonna work a bit differently. First of all, I'm gonna tell it it's 256 because we know it's that. Sprite mode single is fine. Don't generate physics and leave it alone as it is. The rest is fine. Apply. Now we're gonna go to sprite editor. You see these little green anchors?
Mm-hmm.
These indicate 9 slices. So they will allow us to stretch something along the sides, which is going to be really useful. So let's go with like 64. 64 is a bit much. 40. 40 is probably good. So let's go with 40, 40, 40, 40. And you see now I have 9 slices. 1, 2, 3, 4, 5, 6, 7, 8, 9. Like that. Hit apply. Close. Okay. Now if I go to this button and I change UI sprite to my highlight, you can see the highlight is this thing around the button. Okay. And if I delete these buttons and duplicate this button, hit Control D 3 times, you have those 3 buttons, and now they have this sort of highlight around them. Okay?
Okay.
Now, perhaps it might be a good idea. I think it's fine like this. I didn't put it all the way to the edge, kind of deliberately, but it may have been a dodgy idea. But anyway, it looks pretty good. So you could have a highlight colored yellow, for example, when you go and select the object like this, right?
Yep.
And it's going to color tint. Let's choose these colors. So for example, normal color will be invisible, right? And then when we highlight it, it'll go yellow, right? And when we press it, it'll go some other color, say green, right? Selected, we're gonna also say green. For now, I'm just putting random colors, and disabled, I'm just gonna hide it. Okay, now watch what happens when you play. See, when you're hovering on it, it turns yellow. When you click it, it goes green. See?
Yep.
That's pretty cool. Now, all the other buttons don't match. This means what we need right now is we need to construct the concept of a prefab. A prefab is basically the idea of an object that can be duplicated because it's always going to have the same properties. So let's create a folder, call it prefabs with a capital P. Prefabs. Hit enter. Okay, prefabs. And we're going to drag this button into the prefabs. Now we're going to delete all the other buttons in all the rows. Okay, now duplicate this button 3 times. Okay, and now duplicate this row 2 times. And now look at this. As if by magic. It's pretty cool, no?
Yeah.
And now we can select another one, and then when we click it, we're gonna swap them. Okay?
Okay.
So that's working pretty well. And remember, because you can just duplicate the rows as much as you want and everything like that, right? So hit duplicate one more time here. And look at this. Now we have 4 rows with 4 buttons. It's pretty clever, no? Okay. Cool. Now, let me think. The interactions are not going to be that obvious because the on-click button is going to be a problem. But I want to show you something about the prefabs. Remember how I said earlier, the prefabs mean that everything gets applied to all the buttons now. You see they're all blue.
Yeah.
Right? That means that they all get the same settings applied if I change them on the main prefab, on this one. So if here, for example, I change the selection from green to, let's choose one of these pre-selected blues, like this. Okay, now you'll see that as soon as I press play, all of them will be blue when I choose them. Oh, okay, there's a problem here. Why did it go green? Let's find out. Because it was already a color. So we made a mistake in the prefab. Let's go back to the prefab, change the original color to white, like this, okay? And actually for the normal color, I think I'm gonna give it the selected color, excuse me, the hovered color, but invisible, like this. And now, because I'm changing the prefab, it'll change all of them right away. And now it's blue. All of them are blue. Understand?
Yep.
Cool. Right, so let's see, what should we do next? What should we do next? Or there should be something that controls the buttons, and perhaps something that swaps them. We should do an animation for that, almost certainly. There's anything else we should do? Well, we should probably split the picture. We should figure out how to split the picture. This is not going to be that simple.
Okay.
Okay, because I actually am not certain how you do it. One thing you can do, right, is you can go to the sprite, ship, and you can change it from single to multiple and then make the decisions that you want. But I think we're going to go with a different option.
Okay.
Actually, we could go with many different options. A shader would be very effective, but I think it's too complicated for you. Oh, let me close this. This is for my other project. Okay. Whoops, this is my other project. Okay, so scripts, game manager. Let's open it. So we said the game manager is going to need a picture, right? For that, we're going to load in a sprite, which I think is going to have to be converted to a texture later. We'll figure that out. Let's remove all of this. Okay, so what you want to do here is you want to type public. Now we're going to make most variables public just to keep it as simple as possible for her. So public. Do you remember what public means? We talked about this before.
No.
So it means that it's going to be a piece of information that can be seen by any other code anywhere else. Any other script will be able to see this, okay? If you make it private...
Why is it public similar, I meant easier to do than private is?
It's not easier to do than private, but it is easier to do than serialized field private. Because there's a lot of letters to type there. So I want to avoid having to type all of those letters for you all the time. So public, and what you want to write now is sprite. Okay, like this. And now let's give it a name. Let's call it puzzle sprite. So we start with a lowercase, because it's a variable. Puzzle, now capital S, sprite. Now semicolon to finish any line. That's the winky face. Save. Control S. Okay, so we got a sprite. And one thing we're going to need is we're going to need a method or a function that allows us to split the sprite. So let's create a method called void. Well, let's create a method by saying void, V-O-I-D, space. And now you're going to need to give it a name. Start with a capital letter and call it split sprite. So hold shift, S, E, L-I-T, and then no spaces, and then sprite with a capital S. Open close round, so shift 9, shift 0, open a squiggly bracket, shift square bracket, hit enter twice, shift close it. That's it, save. Now we've got a method. And inside this method, we're going to take this puzzle sprite and we're going to chop it up. Okay? How is this going to work? I think in a texture, if I recall correctly, every pixel is stored horizontally in one single very long array. So this is going to get mathematically fairly complicated, especially for you. We're going to have to use divisions, modular divisions as well, probably, and everything like that. Now, I'm not really sure how to approach this in such a way that I can ensure that you're going to understand. Let's see. So I'm going to try and explain it to you visually. So let's take a picture. So the picture we have of the ship, right, is about something like this. Right?
Yep.
Now you need to understand that every picture in software is built out of pixels, which are these little squares with colors. Okay?
Okay.
Now the entire picture is made of many of these squares. So if I say that this one is 1920 wide and 1080 tall, how many pixels is that in total? That's not an easy answer. $2,084. Why did you say that number?
I think I saw it somewhere.
Yeah, you saw 2048, but no, it's got nothing to do with that at all.
Oh.
Okay, what's happening here is you need to think about the number of squares. So let's make a simpler example. Suppose you have this, and there's 4 over here and 3. So that would mean there are 3 rows and 4 vertical spaces. How many squares is it now?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Mm-hmm. How much is 3 times 4?
12.
Okay, so the way we get to the amount of pixels that exist in a picture that's 1920 by 1080 is by multiplying 1920 by 1080. That would mean 2,073,600 pixels. Okay?
Okay.
It's a lot. And furthermore, they are spaced horizontally. So when a list of these pixels gets saved, it gets saved like this. Look at how my mouse is moving. From the left to the right, the first row, then the second row, then the third row, then the fourth row, and so on until 1080. So it goes row by row by row by row. This is a problem for you and me because we are looking for this box over here. This means we need to take part of the first bit, which is easy enough, but then we need to skip all of this part and only take the second line. Do you understand? It's a bit complicated. Okay? But the first step would be, let's get those pixels. Okay?
Okay.
So, let's go here, and we're gonna say, we're gonna need an array. Now remember what a pixel is. Remember I told you it's a square that contains what? What do you see as a human being when you look around? Colors. Okay? Imagine this single little tiny little dot made up of a color. So we're gonna need a list of colors. So you're gonna type colors, color with a capital C, color, and now space, and now go colors. Excuse me. Let's add array like this, and now colors, lowercase c. Oh, there you go. Look, it's already suggesting it. Hit the magic key tab. There you go. Equals. And now we're gonna say puzzle sprite. Assuming this works. I'm not actually sure. Yeah, there it is. Hit magic key. It's already there. Dot. Now try typing texture. Okay, that's the one, texture. Hit tab. Dot. Get pixels. Hit tab. It's already there. And not anymore. Get pixels. And now open, close, semicolon. Save. Now we're gonna get all of the pixels. Okay? So what we're going to do is we're going to test that our thing is working first. Okay, so I want you to type void update here. Not vid, but void. That's enough. That's it. Okay. And update, capital U, update. This is a special method that plays all the time. Okay, open, close round. Open a squiggle. It's already done apparently. Sure. Not complicate things here. Okay, and here we're gonna check if the space key is pressed. We're gonna do something. So type if, open a round bracket, shift 9. Here say input, which is where we get the information for the keys. Dot, get key down. There it is, I found it. Open around, hit the magic key right away, tab, dot, type SP for space, close the round twice, open a squiggle, hit enter twice and close it. Save. So this means if you've just pressed the space key, we're gonna call this. Copy this, paste it here, and put a semicolon. Save. Now here I want you to debug, so you want to type debug log, just D-E, there it is, look at it, it's already there. Debug dot L, it's already there, hit tab, open around. Now colors dot length, so colors, there it's already there, dot length, it's already there. Close around, semicolon, save. So what this is going to do is it's going to make our console tell us how many colors we've got. Let's see if the number is 2,073,000, okay?
Okay.
But first, oh dear, I went to the wrong project again. My apologies. I keep going to the wrong project, so that's not good. Let's go to the game manager. Now the game manager has asked us for a sprite. We're going to give it the ship sprite, like that. Okay?
Okay.
So now we're gonna hit play, and now you can press the spacebar key. 2,073,600. Okay? So we got all of the pixels laid out in a straight line. Okay?
Okay.
At least I think, by the way, it's going from bottom to top. If it isn't, well, I'm wrong. We'll find out later. So now it's about figuring out the quadrants. Okay? So let's create a public here. And we're going to say int space and call this one row count. R-O-W, capital C, count. No spaces, potato. Semicolon. So if we have a row count, what else do we need? We have the rows. What else do we need? How many you have horizontally, right?
So the horizontal row things?
Yeah, exactly. Actually, I tell you what, let's change this to an X. Put the letter X. X count. And I'll copy all of this. Paste it here. And call this one Y count. Save. So Y is vertical and X is horizontal. All right. So if we go to the wrong project, if we go back here, X count is 0. No, that's not good. We need to have, say, 2. And Y count is also 2. So we're going to have 4 squares, 4 boxes. Okay, that's what we want. We're going to keep it easy for now. And now we're going to go and figure out how to construct these images. All right, we're going to need a bunch of images. Now, how many images do we need? If we said we have 2 horizontally and 2 vertically. Remember what I told you before? What do you do to figure out how many you have?
You put them in a row like you made the 4, 4, 4, and you did the times thing.
Exactly, times. So if you have a 2 over here and a 2 over here, right? It's 2 times 2 makes 4. Okay, that means we know the total amount of pictures we should have. So what you're gonna do here is you're gonna say, let's go with private now. Private. Sprite. Space first. Sprite. With a capital P, but that's okay. There. Array, which means multiple ones. And call this one split sprites. S-P-L-I-T. Split sprites with a capital S. Yeah, semicolon. Save. Now, if I recall correctly, we're actually going to have to go through making textures first. So we're going to have to take all of those pixels and then compose them into textures. I don't even remember how to do that. It's something that I'll research before next time, so I can then show you how to do it, right? But we're gonna have to put all of those into these sprites, okay? Now, each of these sprites is going to have a certain indices stored to them. So, and it's going to be an array for each of them. So here's what we're going to do. Right here, you're going to say int, it's a number, a whole number, array, and call this one indices. INDICES. Yeah, save, a semicolon, and save. Okay. Now, for this, we also need to figure out the splitting. So let's see if we understand all of this. Remember, we have a big picture, correct?
Yep.
And the big picture has a resolution, correct? And the resolution is 1920 and 1080. That's our resolution, okay? Now we split this in half. This means, how wide is this box going to be? How much is this distance over here? It's half of what number?
1920.
That's right. It's half of this. And how tall is it going to be?
Half of 180.
1080, yes. Okay, so we can divide that, which means we also need to store the resolution of the picture. Okay, so let's save the resolution of the picture here. So go int space x resolution, capital R resolution. We could do a vector to int, we could do all sorts of things, but we're gonna keep it simple. Equals puzzle sprite texture, copy this, paste it here, dot width W. There it is. So that's how large the texture is horizontally, right? Copy all of this, Control C, paste it underneath itself. Y resolution, put the letter Y. Puzzle sprite texture, what do you think? If it's not width, what is it going to be?
Height.
Yes, so type H. There it is. Save. Okay, so we got the resolution both on the X and on the Y. Okay, now we will know how many boxes exist in here. And the reason why we do know is we know it's width, I'm going to call it W, divided by the amount. I'm going to call it 2 for now. Okay?
Okay.
And then this gets multiplied by height divided by 2. Right? Because remember, this by this makes how many we have in here, right?
Mm-hmm.
That's how it works. So we can do the math. We can call it area, for instance. So here we can say int space, call it area size, capital S size, ZE equals. Okay, so we said it's going to be the width divided by the X count. So copy resolution, paste it here. Now divided by, copy X count, paste it here. And then all of this goes in brackets. Multiplied by, open and close another bracket. Copy the Y resolution, paste it here, divided by the Y count. Copy this and paste it here. Save. Now let's see if you understand the logic here, right? So the amount of boxes that we have horizontally, right? which gets split by a certain amount of boxes that we want. In this particular case, we put it to 2, but it could be 40, right? It doesn't matter. So that number, whatever that number is going to be, is going to get multiplied by whatever the length of the picture is vertically divided by how many vertical lines we want. Okay?
Okay.
And that way you're going to get how many pixels fit in one single box, the area size. So here you can say equals new NEW and then space int, open a square bracket, copy area size, paste it here, and close the square bracket. Save. Now, let's copy area size and paste it in the debug. Save. Now let's check if we are correct. So, if we recall correctly, it's 1920 horizontally. We said divided by 2, that makes 960. Okay, can you remember that number? 960? Now let's do 1080 divided by 2, that's 540. So we said this times 960. This means our area size should be 518,400. Let's see if we're correct when we hit space. So hit space. 518,400. We are correct. Right? So let's change the numbers. For example, let's do something large, like 16 by 9. That's crazy, right? So let's take 1920 divided by 16. That makes 120. Can you remember that number?
Yes.
1080 divided by, what did I say, 9? 120. Okay, so let's do 120 times 120. 14,400. So we said 16 on the X, 9 on the Y. Okay. And now we're gonna say play, and then when you hit space, we're expecting this number over here. Hit it. Whoops, hit it now. Is it the number we have? 14,400?
Yes.
There you go. So we are right. Our mathematics work correctly. Okay? So we've got the indices. We got how many we need. Next time, we're going to figure out... Actually, wait. Can we... let's continue a little bit, okay? But we're almost running out of time here, because we've been doing this for a while, okay?
Okay.
So, let's see. Again, we need to think this through. Let's go back down to having 2 and 2. Okay? Let's think of the math. It's very important. So we're going to draw another rectangle over here. And we're going to say that this is 16 times 9. Okay? And now we're going to figure out if we split it in half. Oh, I can see a problem. Can you see a problem? Can you split an odd number in half?
No.
That's right, you cannot. So we're going to have an issue here if we don't pay attention. Because it's not just in half. Split it in any different amount. Right? So, for example, if you split this in 3 and this in 4, it's going to be fine. But 16 is not divisible by 3. Okay, so we're going to have to make absolutely sure that we split it by divisible numbers. Something important. So we're going to split this by 2 and say this by 3. Okay? Because that's now correct. Okay? Now, we need to know, we know how many boxes there are in here, and that's good. But we need to figure out how to get the boxes. So, all of these boxes have a number. Okay? Now remember, there was like 2 million boxes, okay? Each of them has a number. So in this case, it won't be 2 million, it will be 16 times 9, 144. So there's 144 boxes. So, when we split in 2, right, this bottom row only will go from 0 to 143. Okay?
Okay.
This row. The second row will go from 144 up to 287. Okay, now we need to get half of these and then half of these because those fit in this square. Okay, we need to ignore the second half of these. Do you understand that, more or less? I don't buy that, but that's okay. So, we know that we can divide the horizontal amount of the area for the box. Now, let's quickly check one thing. Do we have the amount of the area? We do, but we don't, because we haven't actually saved these, which we should. So, let's copy these two, paste them here, and call this one X box with a capital B. Box, yeah. And then size with a capital S. ZE. Now copy this. Pass tight. No, wait a moment. Wait a minute. Stop holding control. Pass tight here. Okay. And it's going to be copy this. Paste it here. Now we don't need the brackets anymore. And copy this. Paste it here. And again, we do not need the brackets anymore. Save. And now we can say copy this. Paste it here. Copy this. Paste it here. Save. All right, so now we're calculating the things that we were calculating before, just separately, one by one. And now we have the X box size and the Y box size. So we can say that we go up until the X box size, and then we need to go up a row. Okay?
Okay.
Okay. We're going to need a loop. Now let me think this through for a second, because it will depend on the indices and those specific colors as well, but the indices is what I'm interested in. So we need to loop. We've done loops before. Do you remember what loops are?
A continuous thing that comes back to the start and then goes in some sort of cycle.
Yes. That's pretty good. It's a very layman explanation, but yes. So let's think of code as a linear line, something that progresses. Linear line. Okay. So we're going to say that this is the start and this is the end, okay, of the code. At some point, we reach a loop. So I'm going to call this one LS, the start of the loop. And here I'm going to say the ES, the end of the loop. The LE. The loop end, and then one then continues. Within here, stuff will repeat. How will it repeat? The loop needs 3 parts, okay? It needs a starting point, let's call it SP. It needs an ending point, and then it needs a test. Well, actually, is that the case? No. Actually, the ending point is the test. So test, and then a consequence. Consequence, that's beautifully written. Okay, so a starting point, say for example, we start from the first number. What's the first number in code?
0.
That's right. So we're going to say we start from 0. Then we continue doing a certain thing until a test is met. So we're going to say until, let's call this I, 0. Until I is smaller than the X box size. So as long as I is smaller than the horizontal size, we'll keep repeating a certain thing, okay? And then if this is true, what are we going to do? We're going to say that I goes up by 1, I++. So let's think about this as it goes. So we start from 0. right? We check, is 0 smaller than the box size? The box size on the X, I don't remember the number that we had, but in our example of 16 would be 8, right? So is 0 lower than 8?
Yes.
Yes. Okay. If yes, right, go to I++, so make I go up, and then return to here. If no, what do we do?
You
Exit.
go to the end.
That's right. So that's how the loop works. So it starts here, 0. 0 lower than 8. Yes. Okay. It's not 0 anymore, it's 1. 1. Is it lower than 8? Yes. 2, 3, 4, 5, 6, 7, 8. Is 8 lower than 8?
No, it's the same as 8.
So it exits the loop and it continues. So you can very easily do a repetitive task quickly with computers, thanks to loops. Okay?
Okay.
So let's go ahead and create a loop. So you need to type FOR, for. Now I'm going to teach you a super advanced trick. So FOR. And now I want you to hit tab twice. Look at that. It's written all the code for you. So let's read the code to understand it. Int I. It means you're going to create a variable called I, to which you're going to assign the value 0. That makes sense, right? Because that's the first number. Okay? And then we're going to say I, as long as I is lower than a certain length, we're going to repeat things, and I goes up by 1. Okay?
Okay.
And this is going to repeat. Now, we are actually going to go through Y first. And the length is going to be the Y resolution, I think. So copy this, paste it here, save. Now do another 4. So type 4, then hit tab twice. This one's gonna be X. So we're gonna type X here. And the length of the X is let me think for a moment here. I don't think that we're going by resolution actually. We're gonna go by Xbox, by Y box size. So copy this, paste it here, and copy Xbox size, and paste it here. Save. Control S. Okay. Cool. And we're gonna loop from here to here and from here to here. And the rest we're gonna leave it for next time.
Okay.
Okay? I think, by the way, this is also incorrect. I need to think it through. But thanks very much for watching, guys, and we'll see you again next time, where we're gonna actually split the picture into different smaller pictures that we can then use. Okay?
Okay.
Say goodbye. Bye-bye.
Bye.